Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about e-waste problem in detail. So let's dive deep into it. So what exactly is this problem? Well, the problem was always there. The moment we built PCBs, this problem came to be. Uh, it was always there. Only difference was it's now getting bit out of hand. How out of hand? Well, we are talking bare minimum, optimistically 50 million ton annually. And by the way, every nation's projection is going exponentially. So somebody is saying bare minimum 100 million metric ton by 2035 or something. So yeah, things are getting out of hand. Now what's the problem with this? This is just garbage. So what's the problem? Well, problem is it's non-biodegradable, meaning you can just leave it there. Most of the things are ironically non-biodegradable, meaning nature cannot do much to it. On top of that, it's not safe to store, meaning many times we do stuff, we collect stuff and we just bury it in landfill. This is anti-landfill material, meaning if you put this puppy in a landfill, it's gonna pollute everything around it, from air, water to soil, everything. Things that we use to make this sort of technology is brutal, to say the least. Heck, we were using cadmium, we were using mercury, and you do not even want to look into like all the other heavy material that we use. So this puppy is not only dangerous if left, it's dangerous if it's buried also. So this is very brutal. Now, thankfully, there is one silver lining here, is that it does have valuable building blocks, meaning if you can deconstruct this puppy properly, you're gonna get useful stuff out of it. What kind of useful stuff? Well, copper, valuable, aluminum, valuable, metals, valuable, oh, gold also, valuable, platinum also. So yeah, more than enough value is there. That's the good news. Problem is extracting it efficiently or safely. That's very difficult. For example, right now in India, even majority of African nations are suffering from this, is that most of the places in Europe is trying their best to actually do recycling, but whenever it cost reaches a point where it's like it's too expensive, so company just yeets it. They're just like, what happened to Germany e-waste? It's just like disappeared. Where does it disappear? It came to either India, Pakistan, or Africa. So it becomes a hassle there. Now there people try to do, in case of India, it's a really bad problem. Like, I'm not joking, there are kids, individuals who just take PCB, have a stove, literally use this to just the fumes that is created there. Saying that is brutal is understatement of the century. So it is very lethal on the humanity that is dealing with this, and we cannot just leave it. So they do have the wisdom to like sort it out and like, handle it to the best of their ability, but it is costing them their life, so safety is gone. But if you try to make it safe like all the European nations, then it's no longer efficient, it's too expensive. So these two things is the hard part. And the choice here is that you risk human life, African life, Indian lives, or Pakistani lives, or you risk global ecology. So you have to do something. So this is the problem aspect of it. This is the reason why it's toxic. And I mean genuinely toxic, meaning if it leaches into groundwater, God help you, and 10,000 generations after you. So like, it's kind of shocking that we actually build this with this level of toxicity. So that's the problem. Now, what are the first line of defense? Well, first line of defense, thankfully, is standards. Now, why standard is a good defense? Well, back in the early days of mobile phones, we created way too much e-waste. Why? Every company had its own charging blocks, and European Union realized something very crucial, is that you need less custom solutions for same problem. For example, if there are these two power bricks, what are they? Well, they take AC power input and they eat DC power output. Why the heck they need to be different? Now you'll be like, okay, some could have more power, less power, but here's the deal, they should be in the same language. Like, here's exactly the same thing with your power grid. Like, you do not have to think about it. It's like all you say, single phase, triple phase, or dual phase in case of America. So what phase you have, and voltage and amps. Amps is as in like fuse wise, that's it. You do not have to worry about it. Heck, when was the last time you even thought about what is the hertz of it? Unless you are buying internationally, you do not even have to think about it. So that's the whole point. If the problem that is being solved is the same, as in take AC, make it into DC, take AC, make it into DC, why the heck you have custom solution? Why the heck this will not work with this? The devices that this puppy will work, this will not work. Why? So that's the whole point. Like, powers, communication, things of this nature should not be, let that be very clear, should not be custom. It should be standardized. And we humans became successful because of standardization, like shipping container standardization, railway gauges standardization, electricity standardization. We did standardization, that's why we became successful. So EU, ironically, is the only nation in the world, not nation, I know it's a conglomerate, but they're the only one who had the brains to like, hey, private individuals, I know you can burn the planet, but I have only one planet, let's not burn it. So they did create a solution for this charger mess, and USB charging standard was made. Other than one company that I personally hate, and everybody who likes that company, I hate them too, is Apple. Apple was like, hey, I can just burn the planet for unnecessary reasons. But like, it is what it is. But thankfully, I am at least glad that some humans in this planet know the fact that we have only one planet, and not burning it quicker is a wise thing to do. So EU, thankfully this year, as in when you are watching this video, 2024 should be the last year when we have this problem. Basically, problem of this is a 25-ish watt charger. This is around 50-ish watt charger. Now, this is a big ass power bank. Now here's the deal. Which one do you think will charge it faster? Well, of course, the smaller one. Why? The handshake actually matches. This cannot do the handshake properly with this, so it will not charge at full capacity. So I can literally have a giant ass power bank, power watt charging a power bank. It will be very slow. Unless you have a basically USB tester like this, you're not gonna know whether it's happening or not. So by 2024 end, all of these problems should disappear, meaning any new device that you are buying, mobile phone, chargers, power banks, things of this nature basically, should all have to support power delivery from USB-C. USB-C standard. And yes, this time European Union literally took a iPhone and they were like, we're gonna boom you out of existence if you do not listen to me. We will not allow you to piss around the planet by saying, oh, we were innovation and BS and BS. No, you get USB-C, which is ironic given the fact that Apple is the company that helped USB Association building USB-C. Yeah, very sad. So by 2024, as in this year, end of it, every new device that are being created afterwards will not have to worry about power banks. And that's the primary reason why these things are no longer included with your mobile phone. That is by design, and it's a good thing. Yes, it's going to be expensive for first while. Basically, the people who are in 2024. So people who are going to come into mobile ecosystem, basically kids who are going to grow up and buy mobile phone, they will never have to know about the hassle that this warp charger does not work with this super fast charger and I have to make sure which phone accepts which. They will not have to worry about it. Anything that consumes more than 15 watts of power have to use it by law. So that's a good thing. On top of that, EU also realized that companies will be like, what if we F the customer? So they created an even stricter standard, but that will be implemented by 2026, is that all the laptops that are under 240 watts of power consumption have to use power delivery extended range. Extended range is a 48 volt system, meaning we can easily supply 5 amps of power. This puppy can also do 5 amps of power. At what voltage? Let me read it. Yeah, it can do 5 volts at 6 amps. This puppy can exceed it. So 5 volts, 5 amps is doable. 5 amps of conductor is not that expensive, but if you want to increase the amps from that point, it becomes very expensive. Cables will become way too thick. So to keep the copper consumption low enough, 5 amp was chosen as a limit. It's like we will not exceed 5 amps. Now here's the deal. How the heck you increase the power? Well, increase the voltage. How much? Well, because it's a low voltage device, it has to be low enough where if a child chew through the cable, should not go poof. So the voltage chosen for that is below 50 volt, as in 48 volt. Why? 48 volt is the last voltage that if you touch it, you should not go poof. Hopefully. Nobody has tested it. I should not wish to test it. People have touched 48 volts and they have lived, but it's a bit inconvenient. So the idea is by 2026, we're not going to have to worry about it. Like people have thrown PCs, people have thrown laptops, people have thrown tablets simply because of charging infrastructure issue. All of that should be forgiven, and this will allow less garbage to be manufactured in the first place, meaning a thing you're gonna buy, you're gonna use it forever. Like here's deal, this is an old power brick, by the way, very old, and I'm pretty sure it's like 5 or 6 years old at this point in time, and here's deal, it's still working. It's an awesome thing. It's a good device. It's gonna last very long time. It's just the handshake is the issue. So a standardization is coming to solve all of that problem. I'm happy at least somebody are wise enough, smart enough, and they are firing missiles directly at Apple, and they are also firing at Android. So Android can no longer have like, oh, super fast charger, warp charger, or hulululu charger. No, power delivery. If you are above 15 watts, power delivery, shut up. So that's a good thing. And laptops, they're gonna need some time because 48-volt circuitry is a bit more difficult. But as in, like, the ICs are reaching the market now, so I'm pretty sure Dell engineers are working now. They have USB-C power laptops, but those are very thin and light, low power. 240 watt should cover most of the laptops. So standardization is the first line of defense. Once you have standardization, you create less junk. That's a good defense, and you have tried it, tested it with positive result, and world had benefited from it. Now they are firing even bigger missiles to make sure that oops issues should not happen. It's like iPhone is like, oops, hey, we are following the USB standard because we have an adapter. No, sir, proper USB-C. So all that oops, and Android was like, hey, we support USB-C, but like we have our own Hululu standards. No, power delivery. So that's a good thing. That will allow less waste to be created in laptop, basically portable electronics, which is good. Standardization is a good thing. Then we come to the another aspect, which is a good thing that I have seen, is that long lasting, basically making device that last longer. Now, is that possible? Well, thankfully, yes, we have crossed the potential of what we call exponential growth, meaning a device that you are buying now, it's not gonna be exponentially outranked by something that's gonna come in 2 years or 3 years. Like back in the old days, as in like 10 years ago, heck, I'm getting old, is that we used to watch basically computers ratings. Right now, if you watch any computer CPU reviews and GPU reviews, you will see the lines are very close to each other. As in, like, 30 series card would be here, 40 series would be a little bit next to it if it's a fairly ranked. And same in CPU, 13th generation, 14th generation would be little high, little by little. Back in those days, it was like 2x, 3x. We used to have exponential growth. Now it's common for everything. Back in the days of Henry Ford, we had the same thing. Henry Ford built Model T, and we had exponential growth. Every 3 years, new car was built that was exponentially better than the last one. And then we reached a stagnation. Like 1970s, we reached what we call peak car, where it's like sorted. Like, we started to refine other things, but it was like car was sorted. It's like, this is a car, this is how it's gonna work, sorted. And again, we're gonna add more safety, more seat belts and all that jazz, but car was like sorted. And you can see, like, cars built in 1980s and 1990s, why do people look fondly into it? That was peak car. It was like done. Same with mobile phone right now. Any mobile phone that you are buying in 2020 or 2023 or 2024 is like good enough. It's not going to change exponentially. Of course, there could be some process improvements, which is not going to be exponential. So we reached a point where it's stable enough where you do not have to chase it. Back in the early days of 2010, we used to buy a phone every year because it was getting that. Like, I remember looking at the manual of phones, smartphones back in the day, 512 megabytes of RAM. I was like, damn. And then it's just like, wabam, 4 gigabytes of RAM in smartphone. I'm like, how the heck that happened? That happened very quickly. So we are no longer there. Like, heck, I have 8 gigabyte of RAM in my mobile phone. I'm pretty sure even modern phones only have 8 gigabytes. Like, of course, flagship do go to 12 and all that, but it's not exponential. It's not like 8 to 128 gigabyte. We're not happening there. So stabilization means that any device that you are buying now will actually work for a very long time. Heck, my old computer, second computer that I used it for 10 years. And computer that I'm buying, like I have right now, it should last quite a long time, unless something bad happens. So that's a very good thing. That means we are reaching this point, long-lasting devices. So standardization and long-lasting devices, good thing. And modern devices have a long lifespan for two reasons: because the hardware is mature enough. Meaning, right now, if you are buying a good flagship phone, not only it's a drop resistant, not only it's physically robust, it's also water resistant. Like back in the days, if rain good used to poof your mobile phones. I'm old enough to know that. And nowadays, like, you can just go into swimming pool. Heck, my brother actually shot his OnePlus like a video jumping into a pool. That's a thing that we do now. Like, we do not even think about it. It's like water used to be such a big deal to electronics that now we don't even worry about it. Software, this is another good thing that basically Android is also finally caught up. They're like, okay, let's update the damn thing. Even Samsung is saying, and that's the reason why I went from updating my phone for every 2 years to this time I'm trying to push 3 years. And I'm getting updates, so it is viable. So software and hardware both are reaching a point where you should be able to extend the lifespan of your device. 4 or 5 years should be possible in the horizon very quickly. So that's a good thing. And Chrome OS is making some good strides in that reason, simply because they start with 7 years of life support. So that's good. Now be mindful, that's from the launch, not when you bought it, that's from the launch. Then we have framework laptop. I really like this design, is that we have reached a point where processors and all that jazz have reached a saturation, so to say. So why do we have to have disposable things discarding a long lasting thing. For example, monitor is disposable, it's gonna crack, it can break, or it could just burn out. Or your keyboard, it's physically getting worn down, so why the heck you have to throw the laptop because the keyboard went poof. So having a modular design on this sort of system is really good. And because of this company's splash in the ecosystem, other companies like Google, I'm saying Dell, and other companies, they are saying that they are also going to work on making our laptops far more repairable. And you can see that recently a lot more devices are becoming repair friendly. That's a good thing, we want it. Then we have a Fairphone. That's also an approach of like, hey, remember back in the day when you used to make phones that was actually disassemblable and you can just replace part and just fix part? It's like, wow, we had that. Yeah, we had it. So Fairphone is trying to bring that ecology back. So I'm really happy. Like I'm seeing some good progress in terms of less e-waste creation. Standardization, less garbage is made. Long lasting, less garbage needs to be consumed. That's also awesome. Then we come to the second use part. Now this is a bit tricky. You have to understand, like from outside it may look, hey, we are throwing things that are working. Trust me, if it was working, nobody will throw it out. So that's the first thing. You have to be mindful of that. So finding productive use of old stuff that is productive and cost effective, it's very difficult. For example, there are many offices that yeeted their basically CRT monitor very early on. Now question was why? Well, they had to pay for giant UPSs known as online UPS, double conversion UPS. Those puppies are expensive. Meaning, if you can reduce load on them, that means the lead acid battery banks that you are buying, which are idiotically expensive, you're saving money on that. On top of that, your electrical bill, which is a running cost, you're saving money on that. So people just eat it out of there. Even though many of them are working, heck, you can go into thrift store, most places in USA, and you can still find working CRT. But people still yeeted them out of there. Why? Simply power consumption. So that's one of those things. Many old things keep working. For example, this is a power supply from my second computer, and it's like around 10, I'm pretty sure it's more than 10 years old, and this puppy is working. I opened it up and tested it, everything is working fine. I cleaned it up. Be mindful if you're doing this, something like that, like trying to revive old system, clean it. It had cockroaches, mosquitoes, bed bugs, everything inside. Trust me, go into EVV blog and you will find more than enough electronics fried by bugs. So trust me, make sure you clean it up inside and all that. So I opened it up, cleaned it up, it worked. So now would I risk a brand new system with this puppy? Hell no. Because here's the deal, while everything is working, while I'm getting stable voltage rate, it does have something known as capacitor, it has something known as resistors. Both of them drift, and they drift exponentially more the longer they have to live. Basically, if you test them for 5 years, no problem, just like don't even think about it. 10 years, okay. 15 years, okay, yeah, at this point it's safer for you to just eat that out of there. You can see that in many old hardware repair, like many times people just replace the resistor because the old resistor design we used to use was not long lasting. So many times they are working devices, but like you have to be very mindful of that. For example, heck, many times even modern power supply, as in power supply that is made in 2015, many times you will replace it. Why? Because newer better standards are coming that is more geared toward efficiency. So a corporation that has like hundreds of them, that translates to a lot of power draw. So power hogs and security vulnerability, this you and I don't think about. But if you ever wondered how the heck we are, so many people are getting server grade hardware, like actual server, just yeeted out of there, the primary reason is vulnerabilities. You and I don't think about it. Companies do not advertise it, but many times if they find a unpatchable issue, they're just gonna eat the whole thing. Especially in networking, if they're like, hey, this has this backdoor that we tried to patch it up, it does not work, they're gonna eat it, and they're never gonna tell about it unless you are the some person who is working inside there. And there is a reason, like even you can see that in Microsoft approach, where they're like, dude, you have to use trusted platform module. Now does that eliminate all the risk? Hell no. But does that reduce it? Absolutely. Tested results are 80%. So all the companies, heck, even Dell, HP, all of them used to do it like for a few years ago. Why? Before Windows 11. Why? The reason was clear. It was like it saved money, security vulnerability. So old systems, many times they are working, they are useful, but they still would be removed simply because either they are power hogs or security vulnerability. So you have to be very mindful what you are doing. You do not want to give old gaming system that is like power hog to a school, and you will think I did a good thing, and the school comes back firing missiles at you. It's like, bro, we are going bankrupt because of the power bill. Be mindful of that. So again, it does not mean there is nothing good to be done. There are more than enough things to be done, but you have to be mindful of it. I do see too many people are just like, oh, why don't we just do this? Like, hey, like I repaired it up, desoldered all the wire. I'm gonna convert this into a proper benchtop power supply. I'm going into electronics, so I do need this sort of thing. So it's a good use for me. But That I can comfortably endorse, but I will not endorse like using a very old power supply on a new graphics card. No, no, sir. So be mindful of that. Then we have one of the most amazing thing that I saw is that second life to solar panels. Now solar panels are a static device. They do not have something basically that just physically wears out, so they can last very long time. Heck, they have warranties of 25 years. Now what Germany was going through is that the first initial batch of solar panels that were installed in early 2000s, they are reaching their end of life. Now what does end of life mean? Nothing. It's still working. It's just end of life generally means degradation of around 20 to 25%. Meaning if the panel was 100 watts, it's only giving 75 watt or 70. But here's it's still a 70-watt panel, still a working panel. And will it gonna work for many more years? Absolutely. Panels are surprisingly known thing that we know, and we have long-term testing data that shows like those things do last. How do you think our space stations keep working and our satellites keep working? Panels last very long time unless you do something bad to it, like a hailstorm, like physical damage. If it cracks, it's done. If electrical short happens, it's done. Barring those two things, there are very few things that could damage it. So but Germany realized that they're gonna have bulk load of solar panels just flooding the market. So old technology was like, take the solar panel, it, and then just eat it. Now that's wasteful. What company realized is that they built a very expensive test jig. Expensive as in like having the proper equipment to test solar panel reliably, where you can get the proper voltage and current curve, and when you say that this is a working panel, you can like stand behind it. Those machines are expensive, but they did bought it, and then they were like, okay, they just keep testing all the panels, and 70% of the panels were good. So what they did, 2-year warranty, sold it for exponentially lower cost compared to brand new panel of that wattage. Awesome use. Like this is from Japan, where they were doing a lot of construction work and they had a lot of solar panel. They're like, hey, construction site is not a safe site. You can have rocks throwing around and things are happening. Just use second panel. If it works, awesome energy creation. If it does not work, who cares? It's second hand. So this sort of use is very wise, because solar panel, what is the most expensive part in a solar farm? Well, it's the land. Now here's the deal. Your land area is fixed, let's say 1 square kilometer. That's fixed. You're not going to get more of it. So imagine in 2000, you built your solar farm. Government gave you subsidy, everything was fine, and you're making your money. Your ROI happened in, let's say, 5 years or 10 years. Let's just say. What after that? Well, here's the any panel that is not performing optimally, your profit are going down. Inflation is going on. So what are you going to do? Like, hey, back in those days, 10 to 15% basically conversion efficiency was the GG material. We use that. But here's the deal. Nowadays, GG material is 25 to 30% efficient. Now, companies claim that, but realistically, you can expect 20% or more. Here's the deal. You're going to replace all those solar panels. Why? It's economically necessary to stay competitive and actually increase your power output. So what happens to all those panels? Back in the days, shredded. Now they're like, hey, we can use so many panels in so many rooftop installation where you do not need the latest and greatest in power, but you can reduce enough carbon footprint by A, using them, B, actually producing electricity or using that. So it's a really good use of it. It reduces the basically carbon footprint exponentially, because these panels, again, people have been using it and they are like 5 years on, 10 years on. Panels last very long time, unless broken or like electrically shorted. They could last ludicrously long time. So it's a very good, clever use that I have seen. Second use. Many things can have this sort of second use that will allow a true tangible benefit. Now we come to the most hard part. Physics, engineering, economics. The economics is the hard part of the recycling. That's why many of the European nations, even though they have such a good recycling ecosystem, why the majority of their garbage just disappears? Well, it goes into Africa, Pakistan, India, and all that jazz. Why? Cheaper place. Again, majority of American garbage poofs it. Like America is like, we had garbage, then garbage disappeared. It's like, no, you just sent it to unfortunate places. I live near to it. So that's the economics part of it. So there is value in the waste. Let that be very clear. Are there stuff that is valuable in a solar panel? Are there stuff valuable in the PCBs market? Yes, there is. There is value in the waste, but is it getting it out in low cost is the issue. So what are our tools that we can utilize to make the economics better? Well, first line of defense that I do have to say that many European nations are figuring that out. That's the first line is the weakest link. So they are fixing the first line, sorting. Meaning, if you have a culture that truly focuses on recycling, if you can make sure your individuals, basically your citizens, they are not mixing garbages, you're gonna have a very easy time recycling. Like you're gonna be just like, bro, recycling is easy, bro. It's cost effective, bro. If every plastic is just put in plastic, everything else is in everything else, done, problem solved. Like, that's the hardest thing. If you have mixed garbage, God help you, you cannot save it. Like, flat out. You give a corporation, it's like, hey, this is mixed garbage, try to recycle it. They're like, yeah, it's gonna cost you money. If you give them separated garbage, this truck is only filled with plastic, this truck is only filled with paper, this truck is only filled with metals, they're like, shut up, take money. So that's the biggest weaker link. Sorting. If we have dedicated collections for each category, whatever category it may be, as long as you can have a separated category, it's going to be awesome. For example, let's say hard drive. Let's say you companies like this sell e-waste online basically. So if I were Amazon, I will say, hey, everybody who has a mechanical hard drive, just sell it. If you're gonna buy anything, basically you're gonna buy anything from us, we're gonna have agent coming to you, they're gonna collect the hard drive. We're gonna compile all the hard drive, let's say from India. There's gonna be so much hard drive, we're gonna give you chump change for it. Enough that it justifies it, that is like, hey, I'm cleaning garbage, and not too much so where it reduces. But here's the deal. After collecting so much of it, all you can do, have a machine or an individual just gonna disassemble it. Benefit of that, if you can keep the platters in one side, if you can keep the neodymium magnets, that arm magnets on the other side, now you have a supply of neodymium that is idiotically expensive, which is not contaminated by other things. Corporations that can recycle those will like, shut up, take money, it's actually profitable. Companies that recycle steel, this is just steel, shut up, take money, it's not contaminated by neodymium. Like, yes, you do not want to mix metals, you want to keep metals as isolated as possible from each other. So category, as long as motors, same thing. If you can just say motors go, there's a lot of profit there. The reason why we no longer have that is that everything is mixed. Then we have multiple stages of sorting. It's like, oh, this is an electronic system. Then we have some person will break it, some person will remove steel from it, some person will rip a transformer from it. Then another individual will rip the transformer apart, remove the copper, remove the metals out of it, and then they're gonna send it to other places. Because of so many stages, the cost goes exponentially higher. So category, it's like, if you can really focus on that, it's like same way we build online commerce, same way we have to develop that. So category remains. Basically, we used to do this, like still do this, is like we collect a lot of newspaper. We used to sell it to the people who are walking around. Now we actually collect a lot and actually go to a large place. There everybody sells that. We directly sell it to them, we actually get more money. So category is the key. As long as you can categorize before it mixed, you're good. Second, more advanced deconstruction tool. We have to be really mindful of the fact that we spend billions of dollars making things. We have to actually spend that amount of time to deconstruct it. For example, this is a very good example, video links down below, where they are solving the problem of what to do with solar panels. Like, hey, what do we do with that? Well, here's the deal. When crushing it, you have mixed so many things so thoroughly that the glass is so garbage that companies are like, dude, we can only make insulation wool out of it. It's useless. So what they do is like, they built a system where they have a heating lamp, heats it up to around 200 degrees Celsius, and a cleaver that just cleaves the glass. They crack the glass, just temper glass so it just shatters. They heat it up so glue weakens, and then just cleaves it up. Now the glass is isolated before being mixed with anything else as like minor contamination. It's actually pure enough to be recycled. Now it's like companies that are buying that glass, they're like, hey, this is some good stuff. Same with other machine they have, where they're gonna just grind off silver. Now here's the deal. Silver is expensive metal, but if you mix that silver with something like silicon, yeah, good luck trying to sort them out separately. That's very expensive. It makes it useless. But here, they have a simple grinding machine that removes the stuff, extracts the silver, and then they have a concentration of dust. That dust has 5% silver. Companies are like, shut up, take money. So that's the whole point. We have to deconstruct things. Right now our approach is like, take the stuff, it, and then just like try to sort it out. Physics does not like that. Like, again, let this be very clear. If you were in a ludicrously energy-rich society, we can sort all the problem that way. We are not. We have to pay for the energy. So that's why we have to deconstruct it. These things consume less energy and gives us much better, useful. But it does require this intellectual power, because who would have thought, like, you're supposed to heat the panel, you're supposed to crack the glass, and you have to have a cleaver. And this grinding thing, they are saying this patented, that extracts all the silver out of it. And then they have a different thing that is only silicon. And again, companies like, hey, silicon that is made for solar panels are actually quite high grade. Not semiconductor grade, but they're quite high grade. So that's a useful thing. That's the whole point. We have to deconstruct. And I really like the approach Apple is showing off. Other companies are also working. They have a robot that deconstructs the mobile phone. Same thing applies here. If you can deconstruct parts of it, it's super easy. Like, if you know this speaker module has neodymium in it, you want to put it in a different box. You know this is the battery, you want to put it in a different box. If you can do that without human intervention, because while robots are expensive, they can work 24 into 7 into 365 for many years. So robots can keep working for many years, and you're gonna recoup your cost. And because you have part separation, you can have LCD that directly goes into LCD or OLED, whatever have you, goes into directly glass manufacturing. They were like, bro, we know how we built it, we're gonna deconstruct it, we're gonna get useful material out of it. Speaker people will be like, hey, we got this, how we built it, we're gonna disassemble it or sort it out how we need to. You do not want to mix it. You do not want to like mix the neodymium that is used in vibration motor with a OLED of system. You do not want to mix it. So this is the more approach that we have to take, where we deconstruct things rather than just like buying it, bring it, and this. Like, to give you a context why it is so important, 1 ton of mobile phone that is being collected in India generally contains 250 grams of gold. That puppy is expensive. 250 grams of gold, that's some GG money. But here's the deal. Nobody bothers to do this. Like, why? Well, here's the deal. Compare this to ore. Like, let's say mining dirt from ground and then doing hulululu to it to get gold out of it. That's 5 grams. Now you may be like, wait a minute, why the heck we put up ourselves with 5 grams when we ignore 250? Simply because extracting that, because we do not have deconstruction on it. If we had proper deconstruction for it, it's gonna be like, shut up, take money. It's gonna be actually cost effective. Have the glass that you can recover if you have proper deconstruction like this. Just the glass will actually make it cost effective. Just the fact that you can separate the battery rather than just mixing everything up. All those separation stages, as long as that can be done by machines or something that is very quick, very cheap, very efficient and safe, it's gonna actually be cost effective. So that's what we have to, that's the only way we can solve it. Like, we solve the buying part, like you can buy it. We have to just solve the selling part, where we sell our hard drives, we sell our LCDs. Basically, a company like Amazon can actually do quite amazing things if they want, while making more profit, while reducing e-waste. So that's actually good. And I have noticed that Amazon started to do this. It's like, when they are sending you return offer something, they're like, we're gonna send you the thing, we're gonna just exchange it. Back in the days, it was like, can you send us the return? Then the return went, then person had to come again with the new part. Now it's one thing. A lot of very efficient optimization. Same thing. And we need to build whole ecosystem. That's the whole point. That category part, the deconstruction part, all these things have to work in an ecosystem. You mix it up and then it's like, sort it out. No, that's not gonna work. Even though I've just randomly found out recently that there is a magnetic technology that allows you to separate metals from stuff. Like, if you can make it into powder small enough, it will separate all metals magnetically. Like, wait a minute, how would aluminum be separated? Yeah, it will be separated. Copper, yes, it will separate all metals. All metals is like, heat the metal, put the plastic, rubber, whatever have you, it can do that. Now then, why don't we do that? Well, we do. It's just super expensive, super stupid. Why? The shredding part is expensive. That's why deconstruction, smart, clever deconstruction is the key. If we can deconstruct it without mixing it up, shut up, take money. If we do not, we die. And this is one thing that Elon Musk said that was quite wise, is that the amount of lithium available in a battery bank that is discarded for a car, it is so much lithium that the world's richest mine is like, bro, it's exponential. Like, same way, 5 gram versus 250 grams, same thing. But we don't recycle it, because everybody is going in that direction, where it's like, what if we shred it and then solve it out? It's like, no, you have to deconstruct it. Like, same way we construct it, we have to figure out how to deconstruct it. Of course, that will require some engineering mind, but should be doable. So that will solve the economics part of it. It will solve the contamination part, and it will solve our problem. And this will also keep the new supply chain under control. So if everybody is sorting neodymium properly, the China will be like, we're gonna F you neodymium supply. World will be like, hey, recycling cost? Yeah, we're gonna pay more money to you. China is going lol. China is like, hey, bro, don't take it seriously. So that's why, like, price, throttle value. And there is an equilibrium point where new creation should not be needed. Why? Population has reached a stagnation point. So we're not going to need exponentially more. And our things are lasting longer, more standardization, more better second use. We don't have to worry too much about it. So economics can be solved with some good ecosystem structure. If you build the ecosystem around it, it will be solved. So this was my presentation on basically recycling e-waste problem. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.